In today's JavaScript problem, we're going to dig into a code example provided in the book Eloquent JavaScript, 3rd edition. This was a request from a supporter, and it contained some good information. Specifically, this problem will illuminate some important concepts like the symbol iterator interface, prototypes and classes, and the use of subclasses. Welcome to another tutorial from All Things JavaScript. As always, make sure to click that bell button and subscribe. And remember the discount links to all my courses in the description. Also, if you'd like to support the channel, I provided a Patreon link. One more thing, I've begun publishing JavaScript articles on Medium, so if you'd like additional resources, please follow me there. So let's jump into this. I've been told this code example is a bit difficult to understand for those working their way through this book. And by the way, this book is online at eloquentjavascript.net if you want to take a look. The example comes from Chapter 6, The Secret Life of Objects. Now, this video may be a bit long, but I think it contains some good information if you stick with it. I will primarily focus on the JavaScript concepts. I won't dig into the example code as much because I want to focus on the concepts. Sometimes I think the examples can get in the way of what they're trying to teach. Now, the author, Maren Haverbeck, I believe that's the way you pronounce it, is talking about important concepts in OOP, in JavaScript, and weaving in some other concepts as well. I will link to other tutorials in the description that will provide a good grounding for this discussion. So you may want to take a look at those first. The code example he provides is used to illustrate, among other things, how we can attach an iterator to our own objects, an object we've created. So I want to talk about that first. An iterator is a standard way to produce a sequence of values and is implemented with a next method. An iterator is commonly used with the for-of loop. The for-of loop takes advantage of the next method in an interval to make a slick way of accessing values. Now, this can only be used on iterables. Some examples of iterables are arrays, a node list, a string, so it can be used on those. But we can create one for our own objects as well, which is what we're going to look at. But first, I want to take a look at this iterator method that allows us to do things, for example, with a for-of loop. So I'm going to jump to the console here. I'm just going to do it there. And I'm going to create a for-of loop. And I'm going to do it on a string. Now notice what happens. I'm just going to log to the console the variable j. Notice what happens when we use a for-of loop on a string. It goes through each of the characters one by one and displays it. Okay? And that is possible because the string object wrapper provides an iterator method. This method returns an iterator object that makes using a for-of loop possible. So let me look at that really quick so you can see that, because we're going to be dealing with this in the example. So if I declare, let's just call it iterator obj, and I'm going to set this equal to string. We have a string there. Now, the string object wrapper, as I said, provides access to that method. Well, how do we get access to that method? Well, the method is identified with a symbol so that it's always unique. That way we cannot accidentally override it with stuff we're doing with our strings. Now, if you need a refresher on symbols, that's one of the links I provided in the description. Anyway, we can reference or use that symbol to reference the method. So that's what I'm going to do here. I'm going to use square brackets, which will cause the symbol to be resolved. And here is the symbol we're using. Symbol.iterator. That is provided in JavaScript. It's there. And that particular symbol, that points to that method that we're talking about. So since that's a method, I can go ahead and put parentheses after that to invoke it. So let's see what we get back. So when I press return here, and if I take a look at this variable, we have a string iterator. That's what it tells us. Okay, so we did get an object back. And notice what one of the methods on the prototype is. The next method. This next method makes it possible for the for of loop to iterate through that iterable. It could be an array, it could be a string, it could be a node list, like I said. Now, we can access the next method directly as well. So if I do .next off of this object, it immediately displays the first letter of that string right here, T. And if I do it again, then it goes to the next one, H, and so on. And so that next method is used by the for of loop to allow us to iterate through all of those values, okay? Now, notice what the next method returns. It's an object that has two properties. A value property has the actual value, and then a done property that's set to false. Once we've gone through all of the items in that iterable, that done property is set to true, indicating there's nothing more to display with the next method. This is important to remember because this is what we will be implementing a bit later. So, knowing that, that is the premise for the example that's provided in the book. The example shows how to add this ability to your own object. So that's what we're going to look at, is code that allows us to do that. Don't get hung up in the class that's created to create an object. That is just the example. We're looking at how we want to add this ability to the objects that are created from that class. So what we're going to do is use a matrix class. That's what he uses as his example, a matrix class that will create objects that can represent a matrix. And specifically, I'm going to do like a timetable, x times y, and we'll show the product of those. That's what I'll do with this matrix class. But you could do a lot of different things with it. So let me first paste in that matrix class. And here it is. It's a class declaration. We have a constructor. This is always called whenever an object is created from this class. And so this will set up the initial matrix, and it actually assigns it to this array. Content, that's where it's stored. Here we are establishing the values in that matrix. Now the way this is set up, we can specify the width and the height of the matrix, and then we can pass in a function that will determine the value that's placed at each position in the matrix. So that function we pass in as well. And then it has a couple of methods. A get method to get a value from a particular position, and a set method to set a value. Now in the class syntax, any methods down here are going to be added to the prototype of any object that's created from this class. So an important concept that we're dealing with, all right? Now, like I said, I'm going to use this matrix class to set up a multiplication table. So I just want to put a statement down here to create an object from it. So whenever we create an object from a class, we have to use the keyword new. I'm making it a 7 by 7, and here's the function I'm passing in. We're just going to take the x and y value and we're multiplying them together. That's the value that's going to be in the matrix. And then I'm going to use the get method to just take a look at that. So let me go ahead and save that. And we'll refresh and see what we get. So we get 6. All right, now so you can see that it set up this matrix, let me go back to the code really quick. And I'm just going to uncomment this console log statement. I want you to be able to see the content. That's the array that contains the matrix. And then when we refresh, here is our matrix. And so you can see our multiplication table. It goes as high as 6 times 6 because it's 0 based. So I did a length of 7, a width of 7. So 6 by 6, and that's 36 at the end. Okay? Now, since I've made an object out of this, let's just look at the object really quick because I think this shows an important thing. If I open up that object, we can see the properties. Where are the methods that's on the object? Well, those are on the prototype, and we can see those there. Get and set method, all right? So those are on the prototype. Now, wouldn't it be nice to make this object that I've created an iterable so that we can cycle through every value. We could do it with a for of loop. So there are a couple ways we can approach this. The book creates a new class and then includes an object from that class in the method that it attaches to the prototype of our matrix class. And so I want to show that first. But we could also simply attach another method here within the class constructor, and I'll show that in a bit. So let's do it first the way the book does. And so I'm going to copy in a new matrix iterator class here. Right there. There's our new class. Basically, this is going to make it iterable. And how does it do that? Well, the way we make something iterable is we have to set up a next method, which we've done here. So this next method will allow us to cycle through all the values in the matrix. And the next method needs to return an object. It needs to return an object with a value and then a property of done. And the done property should either be false or true. If we've gone all the way through all the values, the done property will be equal to true. And so that's what this is doing here. Then it sets up the value, what it wants the value to look like. And then we eventually return that. Okay? So that is the matrix iterator. Now, how do we assign this to the prototype so that it's usable? Remember, in order for this to work with the for of loop and to make our object iterable, not only do we need to have a next method defined, but it has to be assigned to a method that uses the symbol.iterator, that uses that value, that unique value, because that's what the for of loop will look for. All right, that's what, and that's why we need to set it up that way. So the way we can do that is this right here. We go to our matrix class dot prototype, so we're assigning this to the prototype. Then we use the square brackets again, so this will be resolved, and so the value of that will be the property that we're assigning to. And since we're assigning a function to it, that is going to be a method. Now the function that we're assigning to it is simply creating a new object here. All right. So remember, that initial method returns an iterator object, and then that object has the next method with it that allows us to work through values. And so this object is going to be returned. It will have the next method on its prototype, so it does have a next method available. So we will be able to iterate through that. So let me just, to show that works, I'm just going to use a for of loop here. Save that, we'll jump out and refresh. I need to create my object first before I try to, my matrix object, before I try to use a for of loop on it, which I'm doing right here. I need to make sure I create that first. That's why I was getting that error. So let's do this again. Refresh. And now we're seeing our matrix printed out. And this is what it's printing out for us. The for of loop is printing each value, those are, and the product of them, because they're multiplied together. Okay, so that's what we're getting there with this for of loop. All right, now to illustrate the prototype here, let me just take a look at M again. Here's the prototype. What's on the prototype? Well, we have these two methods we created before, and now we have a new method. And look how it indicates. It's a symbol. It's a symbol that represents that method. And so it's a unique value that cannot be overwritten. All right, and that has a function with it because it is a method. All right, now I said there are two ways to do this. In the book, it created a separate class to create an object, and then it attached to the prototype that way. I said we could also just put it as another method when we set up our class here. So that's what I want to show you next, how we would do that, because I think it's important to see that as well. And so I'm going to copy in. And here's where I would put that new method. Notice how I define the method name. Here we just type it out, but here I've got to use a symbol. And I want to use a specific symbol, one that's defined already. So symbol.iterator, and I use the square brackets, so that will be resolve, and then the parentheses, because that's the syntax for setting up a method in a class declaration here. And then basically what I've done with the code, just to differentiate from the X and Y value up here, I just rename this to matrix X, matrix Y. So it's a very similar code to what I have down here, but I've just modified it a bit. Now, I'm going to comment out this part here. Save that. I just want to show you that it still works. Refresh it. We're still getting the same thing. So that still works doing it that way. All right. Now I want to go back to the way the book does it. So I'm just going to comment out this method here. Whoops. Get the whole thing. Just going to comment out that. Let me make sure things are still working. And they are. Okay. Now, the one last thing I want to talk about he does in his example. And a bit later in the book, he builds on the same topic. He builds on the topic of inheritance within the class structure. And this is accomplished by creating another class that makes use of a class we've already built. And we can take advantage of what is already there and then modify certain properties so that they are a bit different than the original class that was created. Now, the new class that he creates is called symmetric matrix because it creates a matrix, but it enforces the matrix will be symmetrical. Once again, don't get caught up in the example. This is a concept we want to talk about here. So I'm going to paste that code in, and then we're going to talk about a few keywords here that are used. These have to do with the class structure, class syntax, okay? So if we want to make use of a class we've already created, we use the extends keyword. And so extends creates a class that is a child of another class. And so what we're doing is symmetric matrix is going to be a child of matrix. Now, because it's a child of matrix, it can access anything that matrix provides. And one thing it can access is its constructor. Now, the symmetric matrix will have its own constructor, and we pass in only a size and then a function. Because it's a symmetrical matrix, we only need one number because we're going to make it exactly the same. Then it takes advantage of what we already have done in matrix by using the keyword super. Super calls something from the parent class. So this is a child class. Super is going to call, because inside a constructor, is going to call the constructor from the parent class. And it's going to pass in size, and then this function here. Okay, this is the function that gets passed in. Now, what about the function that we can pass into symmetric matrix, this one here? Well, that is used here and here. So the function that we pass into the matrix class from this symmetric matrix class makes use of the function that's passed in and then does some other things. And all of this is to make the matrix symmetrical, all right? Now, one other thing it does is it overwrites the set method that's in matrix. It overwrites it so that whenever the set method is called from an object that it instantiated using symmetric matrix, it will use this method. But it wants to take advantage of some of the things that were defined in this class. So once again, we use super to call the set method of the matrix class, okay? So that's what super is doing here. That's what extends is doing here. Now, once again, we can set up a matrix from this class. I'm just going to do that really quick. And we only have to pass in the one number. I'm going to do a multiplication table again. I'm saving that. Jump out. Refresh. Here's the two values that we got, the console log statement. So 2 times 3 is 6, 3 times 3 is 9. We're using the get method from that. Now, one more thing before we end here. I just want to take a look at these two again. Matrix. If we take a look at the object we created from the matrix class on the prototype, we see the get and set method, and we see the symbol method here. All right. Now, what happens if we take a look at the object instantiated from the symmetric matrix class? That's what I want to do next. So what happens is we look at the prototype. It has a set method. And it has a set method because if you remember, we did put a set method in here. We overrode the set method that is part of the matrix class. If somebody uses a get method like we did here, it's not going to find it in this class. It's going to go up and get it from the matrix class. All right. Now, how is that represented in JavaScript? Well, let me go back here. We can see the set method is on the prototype for this, but if we then continue at the prototype chain, now we see the get method and the set method. This one here is used instead of this one because it goes up the chain. I'll find this first. It'll use that one. And here is the iterator method as well. That's available on the prototype. So that's the way prototypes are established when we're using this class syntax. All right, this has gone way too long, but I hope it was helpful. And remember, if you're looking for more JavaScript content, remember the discount links to all my courses in the description. I've got a brand new course that's doing quite well. Also, click the bell button to be notified about new releases. I release tutorials as often as I can, and thanks for watching.